Hello, good day everyone. So welcome to our Math A class. Before we start to our next lesson, let's have first a recap on what we discussed last meeting. So we already discussed about an angle. So what do you mean when we say an angle and how angle is formed? So when we say an angle, it is formed by two rays which share the same endpoint. And that endpoint, we call that one as our vertex. And we have also, I already introduced to you the kinds of an angles. So first, we have the acute angle. So when we say an acute angle, so acute angle, it measures between 0 to 90 degree. So it means from 1 degree to 89 degree, we classify that one as a acute angle. And the second one is the obtuse angle. So when we say an obtuse angle, it measures between 90 to 180 degrees. It means we have from 91 degree to 179 degree, we classify that one as obtuse angle. And the third one is a right angle. When we say a right angle, it measures exactly 90 degrees. And the last, which is the straight angle. So straight angle, it measures exactly 180 degrees. So today we have our new topic, which is the angles and the radians. So let's have first our objectives. So first, we have to determine the initial and the terminal side of an angle. Next, we have named the quadrant in which each angle lies. And then we have to convert degree to radians and vice versa. So we have this one, we have an angle measure. So we all know that angle is formed by two rays. So this is our two rays and it shares the same endpoint. So this is our endpoint wherein our angle meet. So we call this one as our vertex. So when we say an initial angle, so this is the starting point of our angle. So this is our initial side. So when we say terminal side, so we're in your angle or this is the end of your angle. So or what angle is the degree measure. So for example, if our initial side is 0 and our terminal side is 90 degree, so our initial side is 0 and the terminal side 0 and the terminal side is 90 degrees. So we have standard point. So if this is our angle, this is our initial side and this is our terminal side. So what do you mean when we say a standard position? So we have three definition for this one. So first we have vertex on the origin. So what do you mean when you say origin? So it is exactly 0. So this is our origin. So 0. First is the vertex on the origin. So this is classify that one as our standard position. The second one is the initial side on the positive x area. So if this is our Cartesian plane, so this part is the positive area or the positive axis. So when you say standard position, so you only have your x-axis must be on positive or from quadrant 1 to quadrant 2. And the third is the terminal sides move. So you will have to move the terminal sides either counterclockwise or clockwise. So we have the word quadrantal angle. So what do you mean when you say quadrantal angle? So have measures that are multiples of 90. So multiples of 90. So ano na siya? So we have 90, 180, 270, and so on. So if this is our Cartesian plane, so we have this is our quadrant 1. So we start this one with our origin. So quadrant 1. So it two positives, and this is our quadrant 2. So we have negative and positive. For this is our quadrant 3, negative and negative. And then quadrant 4, which is positive and negative. So what are our quadrantal angles? So first we will have start with 0, or this is 360 degrees. Next we have 90 degrees, of course, and then we have 90 plus 90, so we have 180, or halfway our circle, and then we have 270 degrees. So let's have name the quadrant in which each angle lies. So we have 50 degrees. So what is the quadrantal angle of 50 degrees? So we have, if we will look on our Cartesian plane, so it is in the quadrant 1. And then the second one is 208. So if you will again look on the Cartesian plane, so we have, the answer is quadrant 3. Next, we have negative 75 degrees. So, for this case, we will have to subtract 360 by 75. So, since it is negative, so we will have subtract 360 minus 75, which is 285. And 285 lies on quadrant 4. Okay, how about negative 110 degrees? 420, and we have 515. So let's start with negative 110. So we have 360 minus 110, we have 250, and 250 lies on what quadrant? We have quadrant 3. Next, we have 420 degrees. So negative 420 degrees. So since our circle is only and with 360 degrees, so 420 we will have to deduct by 360. So the answer will be 60. And what quadrant did 60 lies? 60 degrees. So we have quadrant 1. Same with this one. So 515 minus by 360, which is 155, and 155 lies on quadrant 2. So we have radian. So what do you mean when I say a radian? Okay, so 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So this case, so if this is our circle, so this is our initial side, and this is our terminal side. So this is our arc length, or our radius. This is our radius, and this is our arc length. So we have arc length is equal to our radius when our angle is equal to 1 radian. So in general, we have an angle is equal to S over R, where this symbol, we call this one as our angle, and then this is our arc length, which is our S, and over or divide by our radius. Okay, so we all know that radian is equal to 3.1416. So where does 3.1416 comes from? So we have, so if this is our starting point, so and then we'll have to get this is 1 radian. So from this one, and then we have 2 radian, and then 3 radian. So this is our 3 radian. And then we have small part for this one in order for us to be halfway a circle. So this is where the value of pi comes from. So when we say 3.1416, so the number of the die to get halfway around the circle. So it means we have 3.1416 is our measure to come in order for us to be on halfway a circle. So this is where the 3.1416, which is the value of pi, comes from. Okay, so let's have conversion of between degrees and radian. So we have our formula to convert degrees to radian. We have multiply degrees by pi over 180 degrees. And to convert radian to degrees, multiply radians by 180 degrees to pi. So we have an example. We have 45 degrees. So we have, since it is degrees, so don't be confused. So on our formula, so when we say degree, so degree to radian, so it is important that your degree must be also in your denominator so that you can cancel this one. So we have 45 multiplied by pi over 180. So next, we have multiply 45 degree multiplied by pi, which is 45 degree pi over 180 degree, and then cancel the degree. And then we have 45. So simplify 45 and 180. So we'll have to divide this one into 45. So 45 divided by 45. So we have 1. So we have only on our numerator, which is pi. And 180 divided by 45, which is 4. So therefore, 45 degree is equivalent to 4 over pi radians. So let's have another example. So we have 120 degrees. So again, our formula, 120 degrees multiplied by pi over 180. So 120 degrees multiplied by pi, we have 120 degree over pi, and then divide by 180 degrees. So you will have to cancel the degrees here in our numerator and our denominator, and then simplify 120 and 180. So therefore, you will have to divide this one into 60. So 120 divided by 60. So we have only 2. So we have on our numerator, we have